Hello everyone, the question says that a parallel plate capacitor with plate area 1 meter square each are at separation of 0.1 meter. If the electric field between the plates is 100 Newton per coulomb, the magnitude of charge on each plate is, taking epsilon equals to 8.85 into 10 raised to power minus 12. As we know formula to find out electric field, that is E equals to sigma upon epsilon naught, where sigma is the density and electron density. Sigma, we can write sigma as charge per unit area, that is it's a surface charge density, that will be equals to Q upon A. Epsilon naught will be as it is. Now on multiplication, so we get Q equals to A E epsilon. Now we have given area A is 1 meter square, value of electric field is 100 Newton per coulomb, and epsilon naught is 8.85 into 10 raised to power minus 12. Now on solving this value, we get value as 8.85 into 10 raised to power minus 12, and this will equals to minus 10 coulomb. Hence, so right option is C. Hence option C is right. I hope you understood this explanation. Thank you.
Hello, we are given with a question, and the question says the charge on a capacitor plate in a circuit is a function of time, right? So charge is a function of time, right? That is dependent on time, correct? As given by the question. What is the value of the current at t equal to 4 seconds? So we have to find the value of current, right? What is that at t equals to 4 seconds? So that means I of 4 is what? Right? Since we have current to be equal to dq by dt. That is the relation. So as a function of t, we could write this as dq of t by dt. Right? So from here, since this is showing charge here, q of t and t, right, in micro coulomb and this in seconds, right? So from this figure, we have to find it at t equal to 4 seconds, right? So t equal to 4 seconds is here. So at t equal to 4 seconds, dq by dt, the derivative is what? Slope. Slope is nothing but the derivative, right? So at 4 seconds, t equal to 4 seconds, right? Slope is equal to 0. Right, that implies that dq of t by dt is equal to 0. Right, there is no change at t equals to 4 seconds, which implies that current at 4 seconds would be equal to 0. Right, so our answer is option B. Thank you.
Hello everyone, let's start the question. Question says that in the figure shown below, the charge on the left plate of the 10 microfarad capacitor is minus 30 microcoulomb. The charge on the right plate of the 6 microfarad capacitor is. So in the question, it is asked to find the charge on the right plate of the 6 microfarad capacitor. Okay, and it is also given that left plate of 10 microfarad capacitor, that is this one, having the left plate minus 30 microcoulomb. So this side the charge is minus q, so this side will be plus q. So this side is plus q, so this will be plus q, and also this will be plus q, and this side it will be minus q, and this side the charge will be minus q. Okay, so we have to find out charge on the right plate of 6 microfarad. Okay, so if we see here that the charge is dividing to 6 and 4 microfarad capacitor. Okay, so if the charge for this is q, then for this one, let's say it is q1, then this will be q2. Okay, so that the sum of the charge will be q. Okay, now we know that the charge is related to capacitance and voltage. Okay, but the voltage is constant, so we can see that the charge is directly proportional to capacitor. Okay, so for For these two capacitors, we can write for Q1 by Q2 equal to C1 by C2. Okay. If we take reverse of that, we can also write Q2 by Q1 equal to C2 by C1. So why are we doing that? We have to find out this one, Q1 plus Q2. So if we get Q1 plus Q2, okay, and the unknown is Q1, then we will able to calculate the charge on this capacitor. Okay, so we are trying to find Q1 plus Q2. Okay, so if we add both side plus 1, then in the upper part it will be Q1 plus Q2. Okay, so here we can write Q2 plus Q1 divided by Q1, and here we can write C2 plus C1 by C1. So if we see that in the question, this is given means Q1 plus Q2 is given, that is Q. Okay, and C2 is also given, C1 is given, and C1 is given. So we need to find out Q1 only. Okay, so if we substitute the value here, if we substitute Q2 plus Q1, that is Q, okay, by this Q1, and this will be equal to C2 plus C1 by C1. So Q is given minus 30 microcoulomb, and we have to find out Q1. C2 is, we can see here, the C2 is 4 and C1 is 6. So we can write C2 is 4 and C1 is 6 divided by 6. Okay, now so we can write minus 30 by Q1, here 10 by 6. So Q1 will be minus 30 into 6 divided by 10. So here 0 0 cancelled out, so it will be 18. Okay, minus 18 microcoulomb. So if we see the question, it is asked to find out on the right plate. So if we see that in the right plate it is minus Q charge. Okay, so our answer is already in minus, so it is correct. The charge on right plate will be charge on right plate is equal to minus 18 microcoulomb. Thank you. Hello everyone, let's start the question. Question says that a parallel plate capacitor having capacitance 12 picofarad is charged by battery to a potential difference of 10 volt between its plates. The charging battery is now disconnected and a slab of dielectric constant 6.5 is slipped between the plates. The work done by the capacitor on the slab is, so we have to find out the work done by the capacitor. Okay, so work done in this case will be the energy initial minus energy final. So we have to calculate this one. Also in this case we see that the capacitance is C equal to AE is epsilon naught by D, but when we insert the slab, the capacitance is changed to C dash, and that is the K times, that is 6.5 times the A epsilon naught by D, and we can write this 6.5 times C. Okay, now if we calculate the energy initial, this will be half C into V square. Okay, and the C was C, that is 12 picofarad into voltage, that is 10 square. So this will be 1 into 12 into 100, that is 600 picojoule. Now to calculate the final energy, that is U final, it will be half C1 V square, because the capacitance has changed. But here we see that we have removed the battery, so the potential will be here due to only the charge stored, okay, and that is because of the capacitance initially connected, that is C, okay, and the voltage applied that time. So the charge will be C, that is 120, okay, picofarad. So if we write in farad, it will be 10 to the power minus 12, okay, and the voltage is 10. So we can write here the capacitance, that is 12 picofarad. So we can write in farad, it will be 10 to the power minus 12, and the voltage is 10. So this will be 120 into 10 to the power minus 12 coulomb, okay. We have the charge because of the potential and the capacitance. Now we can write the potential in terms of the charge and the new capacitance. So we will write half C dash into the charge by C dash whole square, okay, or we can write 1 by 2 C dash into Q by C dash square. So C dash will be cancelled with 1 C dash, so we can write half into Q square by C dash, okay. So this will be half into the charge we have calculated here, it will be 120 whole square into 10 to the power minus 12 whole square divided by the C dash, and C dash is, okay, let's write this one, C dash will be 6.5 times C, that is, so it will be 6.5 times C dash, and that is 12 picofarad, and if we write in farad, this will be 10 to the power minus 12. So if we solve this, we will get 92 picojoule. Now calculating the work done. So work done is U initial minus U final. The U initial we had calculated, that is 600 picojoule, and the U final is 92 picojoule. So this will be 508 picojoule. This is the work done by the capacitor. So if we check the options, we have 508 picojoule, the correct answer. So we can write the correct answer is 508 picojoule. Thank you.